In this video, we are on next topic, the hierarchical clustering. So it is also known as the hierarchical cluster analysis. It's an algorithm that groups similar objectives into groups called clusters. The endpoint is a set of clusters where each cluster is distinct from each other cluster and the objects within each cluster are broadly similar to each other. So let's have a look on that. So the hierarchical clustering technique is one of the most popular clustering techniques in machine learning. The clustering techniques is divided into two parts, as there you can see, the agglomerative and the divisive. Initially, the data point is considered as individual clusters. At each iteration, the similar clusters emerge with other cluster until one cluster or K cluster are formed. It comes under the agglomerative, so where we get the individual cluster with the iteration and the similar can merged where the other clusters until you can say for the K cluster are formed. In divisive, we consider all the data points as a single cluster, and in each iteration we separate the data points from clusters which are not similar. But in the agglomerative case, we have the similar and a one, but it gets separated the data points from the cluster which are not similar. So each data point which is separately is considered as an individual cluster. In the end, we will be left with n clusters. So while you want to join it, you can use the agglomerative function, and while you have to separate the data points and make it not similar, so in that case you can use the divisive, where at the end we left with n clusters. So next we have the agglomerative approach. Initialization, each object is a cluster, as there you can see in this image, each object is a cluster here that is defined. The iteration, it merged two clusters which are most similar to each other until all objects are merged into a single clusters, as there you can see if they can merged in a single cluster here and most similar to each other. For the agglomerative approach, let's talk about other. There we have the divisive approaches. Initialization, as all objects stay in one cluster, and select a cluster until it's split it into two subclusters until each leaf cluster contain only one object. As we know, it are not similar and it gets separated, so it will be splitted here into two subclusters and contains only one object with the top down here. Next we have the hierarchical clustering comparison. So there we have four: single link, complete link, average link, and centroid distance. While we have making the cluster here, we have to understand these links. Firstly, we have for the single, as there you can see in this it was formed as single, the 5, 2 and 3, 6 within a single link, and the complete link they are separated here and complete the circle here. In the average, we get a cluster in a cluster here which is separate here, that you can see 5.52 and 364. In the centroid, we have many clusters in a cluster defining with a single one, as there you can see for the 5.2 it is defined here 1364. So it is the comparison here you can see for the single link, complete link, average link, and centroid distance. Next we have the limitations of single link. It has the original points and two clusters, sensitive to noise and outliers. So at there you can see in original point, there we see the dots are defining the data here with the clustering technique. While we split it into two clusters, while we are using the single link, so we get the two clusters, which is of here you can see the brown and the blue dots, which is sensitive to noise and outliers. Next we have limitations of complete link, average link, and centroid distance. So as there you can see a big circle with of two circles defining it, and if we can use these three limitations here, we get the red part, black part, and the green part, which is firstly defining for the complete link, and for the whole circle it was the average link, and for centroid distance it is defined as by two green circles. So the complete link, average, or centroid distance method tend to break the large clusters. This is how it can works. So that's all in this. I hope you understand about the cluster, the hierarchical cluster, where we learned the two types of approach and the links and its limitations, how it can works. So that's all in this video. Thank you.